What about part C, 3x plus 2y plus z equals 6? There's no reason to think that wouldn't be a plane as well. What do you notice the exponent is on x, y, and z? The exponents are all the same. All ones, right? When that happens and you're not like multiplying x times y or y times z anywhere, it's going to graph to be a plane. I'll prove that to you later on, but just take my word for it. Now, it shouldn't seem like too big of a surprise, right? That a line in R2 would generalize to a plane in R3. You've already seen that. So it shouldn't be too big of a surprise that a linear equation, which is defined by taking value of x values to the first power and y values to the first power and adding them together, maybe something times x, something times y. So in other words, a line is of this form in R2. Ax times by equals some constant. So a, b, and c are constants, right? Or y equals mx plus b. That's if you solve for y and you change some letters around. That's the equation of a line in R2. Exponent on x and y both 1. It shouldn't be too big of a surprise then if you get, this is a linear equation in R2. It shouldn't be too big of a surprise that a linear equation, and that graphs to be a line, shouldn't be too big of a surprise that a linear equation in R3 graphs to be not a line but a plane. In fact, any equation of the form ax plus by plus cz equals some constant d is going to graph to be a plane. It's a linear equation in space. So the question becomes, how do you graph this thing? Well, it's really nice when all the coefficients divide the constant, because you can just use x, y, and z intercepts to create a plane, triangular plane segment in what we would call the first octant. Ooh, what do I mean by that? I'll explain that in a minute. So let's draw in my coordinate axes. And again, this time I'll make the positive x the axis coming out at you. Positive y, positive z. So if I want to plot points here, I'll make a table that looks like this. 3 columns, x, y, and z. And if I want the x coordinate, the x-intercept rather, I would plug in 0 for both y and z. So that would get me, if I plot those into my equation, that would get, so I plot a 0 here, 0 here, that would get me, and solve for x, that would get me the x-intercept. What would that be? You'd get 3x equals 6, right? So from this, you get 3x equals 6, x equals 2. The x-intercept is 2, 0, 0. What would the y-intercept be if you plug in 0 for x and 0 for z? So imagine, so you're not plugging in 0 here, you're plugging in 0 here. You get 2y equals 6, or y equals 3. And finally, what would the z-intercept be if you plug in 0 for x and 0 for y? Both of these would go away. You'd get z equals 6, wouldn't you? So 0, 0, 6. So just plot those points, connect the dots, kind of shade a little bit, and you've got a plane segment that's part of 3x plus 2y plus z equals 6. So let's see, 2, I'll plot 2, 0, 0 like that. And then 0, whoops, 0, 3, 0 like that. And then 0, 0, 6. So 1, 2, 3, 4, 5, 6. Like that. Connect the dots. And then you could shade it. I'll actually shade in with a real light color this time. If you shade in here, that interior of that triangle is part of the plane. That's what we're talking about. Does that make sense to you?
So it's a specific part of that whole plane?
Yeah, it's just a segment of it, yeah. And it's just a convenience. Now, what do I mean by the first octant? Well, just like in R2, the axes break up the plane into 4 quadrants, the x, y, and z break up space into 8 octants. The first octant is the octant where all the coordinates are positive, right? So this plane segment is in the first octant